Hi, my name is Sonika Kurode, and this is my Charge Tape Lab.
So the purpose of this lab was to observe interactions of charge tape to gain a better understanding of charges. The model includes two pieces of tape charged in the same method, and the computational model just puts the observations that we made into ClosScript. The physics principles involved in this lab are electric charge properties, such as like charges repel and opposite charges attract, Coulomb's law, and the equation for force of charge, which is k q1 q2 over distance squared. The main result of this lab was that we found an excess charge of 7.275 times 10 to the negative 8 electrons on the piece of tape. So here is the model. The system is tape B and the surroundings include gravity and tape A. The initial conditions were that both pieces of tape were 0.2 meters in length. They both had a mass of 0.0002 kilograms. Both tapes are charged the same, and we can reasonably assume this because we charged them in the same method, given that they're the same mass and length. And the only force acting on tape B initially is gravity up.
The experiment we performed is shown on the right.
So for the experiment, we held tape A under tape B, and that caused tape B to rise a distance d, and the net force in the y direction is 0 because the force of the electric force from tape A cancels out the force of gravity. And the distance that we measured is 0.01 centimeters, and I use this equation, force is equal to force of gravity, which is 0.00196 newtons, and that's equal to the equation. And I just plugged all the different variables that we had in to find the final answer for Q, which is 4.667 times 10 to the negative 9th. And this is the charge on tape B. Here's my code. So the first section just includes some constants such as gravity. Next, I have a section for variables, which is the things that we calculated, such as the distance, surface area, etc. Next, I put all the equations in to calculate the number of electrons on each tape, and I basically just put the equation that I just showed you in the experiment slide into the code. And then to create the force diagram, I created two spheres to model tape A and tape B, and then I placed a gravity vector going down and the electricity vector going up. And I printed a few sentences from the things that ClosScript calculated, and you can see on the left the force diagram matches the force diagram that I created, and you can see the results from the equations are also the same as what I calculated. Because the data we input into the code was from the experiment, the final values were the same between both methods with only minor changes in significant figures. We assumed that gravity and tape A were the only forces and excluded things such as air resistance, and we also treated the tapes as point charges at the center of the tape and assumed that each tape had the same charge. So some sources of error in this experiment was that tape A or B could have lost some charge while we were handling them, and the distance measurement may have some human error because it wasn't precisely measured. So for the why and what if questions, why is it important to handle the charge tapes as little as possible? Your hand can transfer charge from/to the tape, so in order to keep the charge consistent between the tapes and for the tapes not to neutralize, you want to touch it as minimally as possible. And if the electrons had a positive charge and protons had a negative charge, the only change would be the signs because the magnitude of the charges would still stay the same. Like charges would still repel and opposite charges would still attract. Thank you for listening to my lab. I hope you enjoyed.